We said already, not all processes require the entire address space from V0 to Vmax. There may be portions of this address space that are not allocated. Also, we may simply not have enough physical memory to store all this state, even if we do need it. For instance, if we have virtual addresses that are 32 bits long, this address space can have up to 4 gigabytes. And if we have several such processes running at the same time, even on a pretty expensive machines, we will quickly run out of physical memory. To deal with this, the operating system dynamically decides which portion of which address space will be present where in physical memory. For instance, in some system with processes P1 and P2, they may share the physical memory in this manner. So the regions marked with yellow belong to P1, and the regions marked with pink belong to process P2. Both P1 and P2 may have some portions of their address space not present in memory, but rather swapped temporarily on disk. And this portion of the address space will be brought in whenever it's needed. And perhaps that will cause some other parts of either P1's or P2's address space to be swapped to disk to make room. So the operating system must maintain information where these virtual addresses actually are, in memory, on disk, since it maintains the mapping between the virtual addresses and the physical location of every part of the process address space. I will talk about memory management in a later lesson, but at very least, you must understand that for each process, the operating system must maintain some information regarding the process address space. We mentioned the page tables, for instance. And then the operating system uses this information to both maintain mappings between the virtual addresses and the physical location where the state is actually stored, and also to check the validity of accesses to memory to make sure that a process is actually allowed to perform a memory access.